Hi everyone. In this video, we are going to discuss one result, but before that, we will discuss a definition of opposite curve and then we will go further. So here we consider any curve in a complex plane. Okay, so let me show it here. So this is our complex plane, right? We have a curve. We define that curve in a form of function which is defined on closed interval AB. You can easily see here. Okay, so this is a curve we have x. That means image of closed interval AB under x will be like this. So it's a curve in a complex plane, right? So this curve we have, the opposite curve of x is denoted as minus x. This minus x is also defined on closed interval AB to C. So what is the difference between x and minus x? Actually both curves have a same trace, getting, but it is in opposite direction. So that means if the starting point of this x is here and ending point of x is here, then starting point of minus x will be this one and ending point of minus x will be this one, and it is defined in this way: x of minus x of t is equal to x of a plus b minus t for all t belongs to closed interval AB. So using this definition also you can easily see that starting point of x is ending point of minus x and ending point of x is starting point of minus x. Okay, so this is definition of opposite curve. So with the help of this definition we are going to discuss one result now. Make a screenshot of it first, then we will go further. So now we are going to discuss proof of this result. Okay, so let us discuss what is a given thing here. We have a curve x, okay, in a complex plane. So x defined on closed interval AB, right, and it is a smooth curve they have mentioned. The second important thing is we have a function f which is continuous. It is defined on set G, where G is an open set in complex plane C, right? And a very important thing is that trace of x, okay, it lies in G. So this is a given thing we have, and what we have to prove? We have to prove that line integral of f over minus x is equal to line integral of minus of line integral of f over x. So this thing we are going to prove. So obviously we will start with left hand side and we will try to bring right hand side. So let us start. So let me consider here, consider integration over minus x f of z dz. See, in previous videos we have already seen the definition of complex line integral. Okay, so same definition I'm going to follow. So as you know, if x is defined on closed interval AB, minus x is also defined on closed interval AB. So limit of that integration will be a to b, right? So by definition of complex line integral we can write f of minus x of t. After that we take its derivative minus x of t derivative dt. But as you know the definition of minus x of t is equal to x of a plus b minus t. In previous, before this result we have seen the definition. In that definition we have already seen. So let us follow the definition. So this is equal to integration a to b f of definition of minus x of t is x of a plus b minus t. Here also I should write x of a plus b minus t and its derivative dt. So let me remove this diagram. So we will have some more space to write. Okay. So now this is equal to, we can write, is equal to integration a to b, right, f of x of a plus b minus t. Now I am going to take its derivative. It will be x dash of a plus b minus t dt. But when you take derivative, okay, there is a bracket a plus b minus t. So we supposed to take its derivative of that bracket also. That means we are applying chain rule here. Derivative of x we have taken. Now I will take derivative of that bracket. A plus b is constant. Derivative will be 0. But see, t is there, so its derivative will be 1, but it has a minus sign, so derivative will be minus 1. So that minus 1 is a constant, so I can take it outside. So you know, yes, so after that what will I do? So a plus b minus t we have, so I am going to put a plus b minus t is equal to u. So let me write here, putting a plus b minus t is equal to u. So you know that when we put anything, okay, first we take derivative and after that we change limits. Okay, so let us take derivative first. Derivative of a plus b is 0 since it is constant. Derivative of minus t is minus 1, I should write dt here. Derivative of u is 1, so I should write du here. So that means what we have got, dt is equal to minus du. Okay, yes. So let us continue here. After that we will find new limits. Okay, so let us see what will be new limits. So this is equal for let me write for t is equal to a, t is equal to a. Let us find the limits of u. If I put t is equal to a here, a will get cancelled, u is equal to b. Okay, and for t is equal to b, upper limit t is equal to b. If I put t is equal to b here, b and minus b will get cancelled to each other, and we will have u is equal to a. So these are new limits we have. So therefore integration over minus x f of z dz is equal to okay, I have written this thing there. So is equal to, what will happen, I should write minus sign here, integration new limits b to a, right, b to a, f of x of, so a plus b minus t, now we have call it as u, so I should write here x of u. Okay, and x dash of, okay, there is no space, so I'm writing here x dash of a plus b minus t is equal to u again. Okay, and yes, dt is equal to minus du. So that minus sign will come outside. It's a constant, no, will come outside, but see already there is one minus sign which is waiting for that. So minus minus plus we will have. So this is equal to integration b to a f of x of u x dash of u du. Now I will simply interchange limits. So you know that when we interchange limits, we should write minus sign outside. So minus integration a to b, I interchange the limits, f of x of u or f of x of t, you can write x dash of t dt. See, as you know, u and t, both of them are variables. So if you change the variables, value of integration remains same. Okay, so if you simply replace u by t, doesn't matter. But did you notice this is definition of something? Yeah, this is a definition of line integral. This is definition of line integral or complex line integral f of z dz, a to b simply, and x of t x dash of t, that means this is integration over x. Okay, so this is minus, I should write here, minus integration over x f of z dz. Actually we started with integration over minus x f of z dz, that means we started with left hand side and finally we got right hand side. That means in this way we proved this result. Make a screenshot of it, then we will stop. Thank you, bye bye.